Hello friends, today I'm going to solve LeetCode problem number 2306, naming a company. In this problem, we are given an array of strings, ideas array, and each of the string represents a name. What we need to do is we need to choose two distinct names from the array. Suppose they are idea A and idea B. What we need to do here then is we swap the first two letters of both the strings from the array, and then we look at the array. Does that array have that swapped strings? If it's not found in the original array, then we are able to create a name for a company. Basically that would be idea A space idea B, and similarly we can also create a name idea B space idea A, because again idea B and idea A, both of them do not have their swapped strings in the array, right, in the original array. If not, we just keep continuing, and then finally we return number of the distinct valid names for the company. Now let's just look at this example here. So we are given this example. So what do? We have a coffee and donuts. So now let's take this as our first string A and this as our string B. Now what we do is we need to swap the first characters of these two string, right? So what do we get after swapping? So we get DOFFE for, and next we get CONUTS. So this is the two strings that we got from by swapping the first characters in each of these strings. Now we look at this array. Do we have these two strings in this original array? Well, toffee, we do not have any toffee. What about coconuts? Conuts, where there are no conuts here, right? So it means that we could form a company name which starts with toffee space and then conuts, and also we could form name such that the company name is conuts space toffee, right? Because these two strings are not in the array itself, so we can arrange these two to form two names. So what do we got is we got two names, right? So by comparing two strings, if the two strings are not present in the ideas array after the swap, then the resulting names we could form is equals to 2. Now we are going to do the same thing with coffee and time. So what do we get is we swap C and T. So we replace this with T and we replace this with C. Now let's look at this. Okay, I'm actually changing my original array. Let's don't do that. So I replace C with T, so I get TOFFE, right? And next I get is CIME when I replace T with C. Now is toffee in this original array? Well, of course we can find this toffee here, right? Which means that we cannot form a new valid name, and hence we move on to the next string, and that would also create the same, because C and T, when we swap them, it again forms toffee and coffee, which are in the original array. So we are going to do that with each of the strings, combination of each of the strings here. So we are going to do that with donuts and time, and that would lead us to a +2 combination, because it would form donuts and dime, and dime is not in the original string, donuts is also not in the original string, so we add a +2, and then again what do we do is donuts and toffee, that would form donuts and toffee, and still that would be distinct, so we add a +2 again, Next, what we do is time and toffee. So when we swap the first two um, characters of this string, we still get the same thing, right? So basically we are not increasing the result, so our result is equals to 6 here. So far, looking at this example, what can we infer? One thing we could infer is that if we found two strings, after swapping them, if they are distinct, then we can actually increase our result by +2, right? So every time we can increment our result by +2. And the next is, if the two strings have the same initials, which means that the starting character is the same, then they would not form a valid company name, because swapping them would form the same string, right? So what are we going to do is we are actually going to group together all the strings that have the same starting name. So we are grouped together strings which starts with C, that starts with D, and that starts with T. So once we group together these strings, so what we get is coffee, okay? So this is what we get for here, and here we got our donuts. All right, and here we get time and toffee. All right, so now that we have grouped together, how do we do the comparison? So what we do is, for C and for D, we take these two groups and then we check for each of the strings in this group and this group. So we take the coffee. Basically, we do not actually need this first character here, because we have already you already know the first character would always be distinct, because we have grouped them based on their initials, right? So we are not going to store the first initial, we only store the string after that. So we have Offie and Onuts. Now what are we going to do is we are going to check, is Offie present in this set, in this group? Of course not, right? And then once we have done that, so the number of combinations that we could form is, the number of valid names is 2 times the length of this group, that is equals to 1, times the length of this group, that is equals to 1, right? Because there are no mutuals here, so that would be equals to 2. Now next we do the same with C and T. So what we do is, coffee is Offie, OFFE, present in this set? Well, yes, Offie is present here, which means that we have one mutual in these two sets, right? So what we do is, to find the number of valid company names, we take 2 times the length of C minus the number of mutuals. Since the length is 1 and the number of mutuals is also 1, so we take that value and then we take the length to -1, so that would give us the value equals to 0. Next, what we do is we take okay, let me use another color. So now we compare this group D and T. So while comparing D and T, we find that there are no mutuals, right? The owners is not present in the set T, so no mutuals. It means that 2 times the length of group D, which is equals to 1, times the length of group T, which is equals to 2, so that would gives us 2 times 1 times 2 equals to 4. So our final result would be 2 plus 0, plus 4, that is equals to 6. So that's our final result. So this is what we are going to do. We are going to group our each of the idea in the ideas array based on the first character of each of the strings, and we are not going to store basically the first character, so we are only going to store the string after the first character, and we are going to compare each of the groups and finally get our solution. So that's how we are going to do. So to create our group, what are we going to do is we are going to use, since there are only 26 characters, right? There are only 26 characters in English alphabet, and we are given that the name consists of only lowercase English letters, right? So which means that the characters are only 26, limited to 26. So the length of our group would be equals to 26, and hence our time complexity would be, well, I'll discuss about time complexity in a minute so our time complexity would be, since we are comparing each group with another group, that would basically depend on the length of each group. So let's suppose the length of each group is n. In the worst case, that is the length of the ideas array, and the length of each string is equals to m, so that would be n times m, because we compare each element in the group with another element, right? So we're comparing that, so that would be n times m. And yeah, now let's start coding. So we are gonna create an array of suffixes, because we do not store the first character, right, initial, so that's why I'm just taking suffixes. Alright, now each suffix will be a group, right? Each suffix is a group, that is, we are going to form a set. So for length I equals to 0, I less than 26, I plus plus, we are going to define each suffix as a set, new set. Once we have done that, now we are going to fill in each of the set. So starting from each string in the ideas array, so we are going to loop over each of the string and index. The index will be determined based on the character initial, the first character. So we are going to take the ASCII value for each of the initials and subtract that by the ASCII value of the first character in the English alphabet, that is A. That would give us the value in the range 0 to 26. 26 is exclusive, so index equals to ideas I dot character code at index 0 minus string A character code at the index 0. So that would give us our index, and at that index of the suffixes, we are going to add our substring, our suffix. So I'm just using slice, we could even use substring. So this would give us so this whole thing, ideas.slice1, will give us a substring starting from the from index 1, and we are adding it to our set, our group. Now once we have done that, we are going to compare, right? So starting from index 0, I less than 25, I plus plus, and then for let j is equals to I plus 1, j is less than 26, j plus plus. So now why did I take I value until 25 and j starting from I plus 1? So what are we doing? We are creating groups, right? We created groups and now we are comparing one group with another groups. We don't want to compare the same group with itself, right? So we compare C with D. So basically if this is at index, this is index 3, right? A is 0, B is 1, C is equals to 2. So C would be index 2, D would be index 3, and let's suppose that this is index 5 just for the sake of our example here, index 5. All right, so we want to compare this group with the next, with all the remaining groups, 2 with 3, 5 until 26, until the 25th, which would be Z. So we compare it with 25th, and once we compare with 25th, we so that's why we are starting j from I plus 1 until 16 and this until 25, because we want to compare the string 24 with 25, right? Because I if it reaches 25, it's just of no use, because 25 means j should start from I plus 1, should be less than 26, and once we do I plus 1, that would be 26, which is equals to 26. So in either way that would not be executed, right? So it's just good to use this thing. Now that this would give us our two sets, so let us get our sets into a string, into a variable. That way it would be easier for us to go through our code. So we got our two sets. Now we are going to compare each of the element in both the sets, right? So let suffix of set 1, so for each of the suffix in set 1 we are going to check if set 2 has that suffix or not. So we do that if this condition is true, then we are going to increment the count of the mutual. So let mutual count equals to 0, so our mutual count is going to increase by 1 each time. So after we have found our mutual count, we are going to set the value of our result. So initially it's 0, so our result would be increased by 2 times the set 1 size, all right, minus the mutual count times set 2 size minus the mutual count. Okay, so far that seems great. So now let's try to run our code. Okay, what's wrong here? Okay, so one thing I did here is we actually need to take the slice of this string, the ID at index I. Okay, let's submit our code now. Great. So talking about the time complexity in this problem, we created an array of size 26. So this is basically a constant time, and this is of n time complexity. This for loop is 25, this is 26, so that would be still be constant. And talking about this, I already discussed that this would depend on the size of each set. So the in worst case that would be O of m, and we are comparing each string, right? So that would be m for the length of the string of maximum length. So that would be O of m times n. And talking about the space, we are using an array, right? We created an array of index 26, and then we are storing each value in the set, right? So basically that would be O of m, O of n, because even though we have an array of size 26, each array is a set, and each set stores all the values from ideas, right? So that would be O of n time space complexity.